Right, welcome to this course. I will start with explaining how electricity works, and then we will continue using that knowledge to build some circuits. First of all, we have a little analogy that is often used in terms of what is electricity. And it's a little pipe, and there is water flowing through it. The pressure of the water, like how much there is push, is called the voltage. Right, so that is one thing. The water pressure is voltage. It's denoted with a V. Then we've got the amount of water that is in this pipe is the current. Current is noted with an A because it comes from amperage. That is important. No, it's not with an A, it is with an I. Excuse me, it is in amps, but the signal is I. So there is an amperage of water flowing through it. What does this mean? It means that if the pipe gets bigger, then there can be more current with the same voltage. Because there is a bigger pipe, there is more water that can flow through at the same water pressure. And if we make the pipe more narrow, with the same amount of water in the pipe, then the voltage will need to go way up because it needs way more pressure to push all that water through. So these two are already interrelated. But there is a third unit that has influence on this idea. So you can note that the size of the pipe, we can say that is the current, or that allows for a certain current. The pressure is the voltage, and then there is the resistance. This entire pipe has some resistance, but we might also just block it somewhere. And now this water, all this current needs to go through a little diminishment, and that is the resistance. Resistance is noted luckily with just an R. Yes, just an R, and is in ohms. I'm writing off page. So that is that. We've got a voltage, the pressure of the water, we've got the current, the size of the pipes, and we've got a resistance, and that is the resistance it can find along the way. These three are all interconnected. I will not ask you to calculate them, but know as an information that the voltage equals the current times resistance. With this formula, you can calculate anything within the three. So if you know two of them, you always know the third. So it's good to know. What is more important to know, what I really want you to remember, is if you look at this as a water pipe system, then that also means it flows from plus to minus. That is something to know. That we always need a closed loop, because otherwise if the pipe breaks and the water flows out and we don't have any water pressure left, we always need to go from plus to minus in a closed system. Imagine there's this water tank with a little pump, whatever, but it needs to be closed. If for whatever reason there's a gap here and the pipes do not touch, that means that there is no flow of water possible, and that means our circuit will not work. Keep that in mind. We always will work within a closed system. Always close your circuits. An open circuit will not work. You can sometimes deliberately open it or close it, but that is intentionally, and you should not. You should keep that in mind, because if something doesn't work, it's the first thing to check. Is my circuit closed? Is there any breakage? Is a wire not sticking in where I needed it to be? What's happening? Also, secondly, to note is that we will, if this is the flow of water and you would just connect it, that's not a good idea. Try to always have a component somewhere, and it can be a light or something else, that makes sure that your current that is running through has some work to do before it ends up back at your power source. We will always work with one or like two and maximum components per circuit. That is the name of the game with Raspberry Pico or Arduino, is that we create separate circuits. We will measure one out of two things. We will either decide, well, not measure, we will take decisions on one of the things. We will either decide how or when current should go, how or when we will push out voltage. Like we will decide if there is water coming in or not. Or there is a component that alters either one of these three through resistance, for example. And then we will try to measure, is there a different current coming in than we used to have? And if this is different, then we know that either the component has blocked it, or has diminished the flow of water, or diminish the flow of energy, and that we can measure. And this is, for example, how a sensor works. If we decide, that is called an output. We will decide when water is flowing out of the barrel. We will decide whether current or voltage is flowing out of our energy source. And if we try to measure something, that is an input. We will try to figure out if something happened to the voltage that came back into our system, right? Note this. This is signed with a plus and a minus on your schematics or in your Raspberry Pico. This will be noted with a 3V3 and a GND, a ground and a 3 volt. This is what we are working with. What to remember, make separate circuits. There's an output if you decide when to power something. There's an input when you try to measure if there has been an alteration of the flow of electrons, of the flow of the current. And the circuit always needs to be closed. That is important.